Welcome to this explainer. Today, we're heading to one of the most extreme, isolated environments on the planet, the McMurdo Dry Valleys of Antarctica. Now, when you picture Antarctica, you probably think of endless expanses of blinding white snow, right? Well, scratch that. Down here, powerful katabatic winds literally strip the landscape bare. What's left is this stark, frozen, completely alien valley of rock and ice. But tucked inside this already bizarre place is something truly disturbing, a visual so dramatic it almost defies belief. Let's dive in and investigate one of the most remarkable natural phenomena on Earth.
Just look closely at the stark white edge, or terminus, of the Taylor Glacier. Right there, against the pristine ice, there's this dark red flow, periodically spilling out, completely staining the valley floor as it creeps toward Lake Bonney below. It looks exactly like a massive jagged wound in the ice that's just bleeding out into the freezing valley. Crazy, right? For over a century, this striking image was a massive riddle for scientists and explorers alike. So why is an Antarctic glacier bleeding?
The whole mystery actually kicks off back in 1911. Early explorers on the Terra Nova expedition, led by Robert Falcon Scott, were out mapping this totally unknown, incredibly hostile continent when suddenly they just stumbled upon this massive, rusty red stain. They were completely baffled by this bizarre waterfall. Unable to explain the chemistry behind it, they just went ahead and dubbed it Blood Falls.
And for decades, the myths just swirled around this discovery. Some people actually speculated it was real blood from some unknown subterranean creature. Or, maybe slightly more realistically, a mysterious bloom of red algae. But the scientific reality? It's honestly so much more compelling. As you'll see, it isn't blood, and it definitely isn't algae. It's actually an extremely salty, iron-rich water source, what scientists call a hypersaline brine.
So here's how it actually works. Deep beneath the glacier, there's this highly concentrated brine, packed with dissolved ferrous iron, just trapped in absolute darkness. While it's locked underground, it actually remains completely clear. But when this brine eventually finds its way out and hits the oxygen-rich surface air, bam, the iron undergoes immediate oxidation. Essentially, it rusts. It's this exact chemical reaction that creates that incredibly dramatic illusion of blood pouring straight out of the ice.
Section 2. An ancient marine origin.
Now, to understand where this hidden iron-rich water actually comes from, we have to rewind the clock millions of years. The climate in Taylor Valley used to be much warmer, which allowed ancient ocean water to flow deep into the region. But then, roughly 1.5 million years ago, the climate shifted dramatically. The Taylor Glacier advanced, expanding right over the valley and acting like a giant frozen lid. It permanently sealed this pocket of ancient seawater underground, completely cutting it off from the ocean and the sky above.
But wait, you might be wondering, why didn't that seawater just freeze solid alongside the glacier over the last 1.5 million years? Well, the answer comes down to a really neat mechanism called cryoconcentration. Basically, when water freezes into ice, the crystal structure of that ice essentially rejects dissolved impurities like salt. So as the edges of this trapped seawater began to freeze, the salt got pushed out into the remaining liquid. Over thousands of years, this ongoing process concentrated that leftover liquid into an incredibly intense, super salty brine.
And because salt naturally lowers the freezing temperature of water, this highly concentrated brine can stay entirely liquid even at -6 degrees Celsius. Think about that. Thanks to the intense pressure from the glacier above, combined with that extreme salt content, this entire subglacial hydrological network just keeps flowing as a liquid, at temperatures that would instantly freeze ordinary fresh water. The glacier is quite literally hiding a dynamic liquid world right beneath its solid surface.
Which brings us to our next section, life without sunlight.
You see, this dark, freezing, salty pocket of water isn't just some dead chemical reservoir. It's an actual hidden ecosystem. Just think about the conditions down there for a second. Extreme cold, high salinity, absolute darkness, and total isolation from the atmosphere. Most ecosystems on Earth rely on sunlight for photosynthesis, right? Well, not here. Here, extremophile microorganisms survive entirely without the sun. Instead, they draw chemical energy from inorganic compounds in their environment, taking part in cycles involving the very sulfur and iron that give Blood Falls its name. They are literally eating the rock and brine around them just to stay alive. It's wild.
And the craziest part is, our understanding of this extreme environment is still evolving. In fact, a breakthrough study published in August of 2026 in the journal Nature Geoscience added a fascinating new chapter to what we know about this subglacial world. This research decided to look beyond simple bacteria, searching for evidence of something much, much more complex. The researchers rigorously analyzed 167 separate samples. They pulled these from aquatic environments, subglacial mud and sediments, and even the red-colored ice directly around the Taylor Glacier terminus. They were essentially hunting for molecular fingerprints, clues left behind by whatever might be living or might have lived in this perfectly isolated system.
And what they found was molecular evidence of relict marine communities. We're talking about microscopic eukaryotes, things like diatoms, haptophytes, dinoflagellates, and ciliates. Discovering the molecular signatures of these complex marine-associated microorganisms is huge. It basically proves that a marine biological presence survived and persisted in this system long after it was physically cut off from the ocean millions of years ago.
Now, before we get carried away, we have to be careful not to exaggerate these findings. You know how headlines can be. They might make it sound like there's an intact, ancient ocean teeming with glowing, swimming creatures right beneath the ice. But the reality is a bit more grounded. Scientists found molecular and genetic evidence of marine-derived communities in the ice and sediments at the terminus. So, while it absolutely strengthens the ancient marine connection, it doesn't mean there's some subterranean sea monster waiting to be discovered down there.
Moving on to our final section, clues for other worlds.
So, why does this weird, isolated ecosystem in Antarctica matter to the broader cosmos? Well, it's because blood falls absolutely fascinates astrobiologists. If we're looking for life on other planets, say in the frozen subsurface of Mars, or maybe beneath the thick ice shells of moons like Europa or Enceladus, we need to know what we're actually looking for. Blood falls acts as this perfect natural laboratory right here on Earth. It proves that habitable zones can remain completely hidden beneath frozen, seemingly hostile planetary surfaces. It shows us that life really can persist in the dark, extreme cold, fueled entirely by chemistry.
Ultimately, the story of this remarkable landscape is a testament to the sheer resilience of life, the awesome power of planetary geology, and a really tantalizing hint at what might be hiding beneath the frozen surfaces of worlds far beyond our own. As we wrap up this explainer, I want you to remember this. Blood Falls is not Antarctica bleeding. It is a rare glimpse into an ancient, hidden world beneath the ice.